Here's number 22. We're going to see that this is a case for exactly one solution. So just like in other problems, we're going to end up having a point of intersection. And the way we would get this one is we'd want to double everything in this equation, because that would give us a negative 2y right there. So I'm going to go ahead and do that. Negative 8x minus 2y equals 16. So now this equation's actually gone and we're comparing these two. So we're going to have cancellation between the y terms, and this will be negative 14x equals 14. So divide by negative 14 to get rid of that. Divide by negative 14, and we end up with x equals negative 1. Plug negative 1 back into either one of the original equations and we'll find out what y is. So negative 1 plus 2y. Now you can see y is the only variable in the equation, so that's why it's going to be solvable. Negative 6 times a negative 1 is positive 6, plus 2y equals negative 2. Subtract 6 from both sides. We get 2y equals negative 8. Divide by 2, divide by 2. 2 is out of there. Y equals negative 8 divided by 2, so that's negative 4. So xy, we have negative 1 comma negative 4, exactly one solution. And if we wanted to make absolutely sure that we got that right, we would plug the x and y values back into each of these equations, and when it spits out some true statement like 2 equals 2, or negative 3 equals negative 3, something that's true, it would just verify to us that we actually did it right. That's how you do a problem with exactly one solution, which is kind of like what we've already been doing in the previous section.